This is AP Calculus AB. We have just finished up our last unit on derivatives, and now we're going to focus on antiderivatives. Antiderivatives are essentially going backwards. You know what the derivative is. What was the original function? Let's focus on an elementary example. If f prime of x is 2x, what is f of x going to be? Now, if you remember the rules for the power rule of differentiation, if you had f of x equals, let's say, x to the n, f prime, we would move the exponent to the coefficient. We would subtract 1 from the exponent. So that's how we found the derivatives with the power rule. So if our derivative is 2x, it stands to reason that if we go backwards, we're going to end up with f of x equals x squared. Let's see if that works. We take the 2 and put it in front, subtract 1 from the exponent, we're going to get 2x. However, maybe it's not x squared. Maybe f of x was x squared plus 1. Because if you take the derivative of 1, you get 0. And that would never manifest itself here. Or maybe it was x squared plus 8. Or maybe it was x squared minus 9. Hopefully you can see we can certainly figure out that 2x came from x squared. But since this is going to be a plus 0 here, we have no idea what this constant was. So our first rule for integration is the power rule, which is the power rule of derivatives backwards. By the way, integration and antiderivatives, those are synonyms. Antiderivatives and integration. Those are synonyms for us. Power rule of integration. So should notice, should point out that this symbol and this symbol are the bread in an integration sandwich. This is read to integrate x to the n with respect to x. This here symbol is a tall, slender s. It really means summation, which we'll get into that more, what that actually means. With the power rule for integration, the antiderivative, we add 1 to the exponent, multiply by the reciprocal of the exponent, and then we add to that some constant. We don't know what that constant is. That is some random number, could even be 0. There's no way for us to know what that is unless we're given more information. And we could say that n could not be -1. If n was -1, this would be -1 plus 1, our denominator. We'd be dividing by 0. Let's see if we can apply this to an easy problem. Find each of the following antiderivatives. Now we have multiple terms, so we're going to take the antiderivative, we're going to integrate each term. So let's take this first one, 3x squared. So we got the 3, we add 1 to the exponent, 2 plus 1 is 3, and then multiply by the reciprocal. If you get to this point and you think, I don't know if I did that right, take the derivative. If I put 3 in front, the 3 and the 1/3 cancels, subtract 1 from the exponent, I get squared. So that checks out. This next one, I got 2 times x. Add 1 to the exponent. This is x to the first. 1 plus 1 is 2. Multiply by the reciprocal. This last one, this 3 is really 3 times x to the 0, because x to the 0 is 1. So if I add 1 to the exponent, it's going to be to the first. Multiply by the reciprocal of 1 is still 1. So this ends up being x cubed plus x squared plus 3x. Whoops, and I forgot something already. We have to always add in this arbitrary constant. It's arbitrary because there's no way for us to know what it is without more information. But if there's a constant here, which there could be, constant could be anything, it could be any real number, could be rational, irrational. When you take its derivative, you end up with 0, and that doesn't appear up here. Number 2, we do not know how to integrate a quotient. So what we can do is we can simplify this. We can divide each term in the numerator by this x, and then we don't have this quotient. So if I add 1 to this exponent, it's going to be x cubed, multiplied by the reciprocal of cubed, that's a third. I add 1 to this exponent here, it's x squared, multiplied by the reciprocal of this, which is a half times 2 is 1. And then anytime you have a constant, that comes from a linear function. So it's going to be minus 4x, and then we add our arbitrary constant to it. This is how you integrate using the power rule. Number 3, we do not know how to integrate a product. So we are going to multiply this stuff out using the distributed property, the box method, whatever you kids are calling it these days. These are like terms, so we are integrating 2x squared plus x minus 6 with mad props to x. So if I add 1 to this exponent, it's going to be x cubed. If I multiply by the reciprocal of 3, it's going to be a third. A third times 2 is 2/3. Plus. Add 1 to the exponent here, it's going to be x squared. Multiply by the reciprocal of 2, which is 1/2, so I get 1/2 x squared. And then this minus 6, which is the constant, that had to come from a linear function, so that would have to come from a negative 6x. And then I add to this my arbitrary constant, which there's no way for me to know what that is. Let's check out number 4. We do not want a radical, and we do not want a fraction. I'm going to rewrite this as integrating 2 times x to the negative 1/2 with mad props to x. Bring the constant down, I add 1 to the exponent. Negative 1/2 plus 1 is 1/2. I multiply by the reciprocal of 1/2, that's 2. Add in my arbitrary constant. As soon as you pull off this integration symbol with respect to x, you got to add in your constant. This is going to be 4 square roots of x plus c. Excuse me. One more, which is going to lead us to our next rule. This is written, if we don't want fractions, if we want to write it in polynomial form, quote unquote, x to the negative 1 dx. Now terrible things are going to happen here. If I add 1 to the exponent, I get 0. And then if I multiply by the reciprocal of 0, I get 1 over 0 plus my arbitrary constant. Now this is a problem. This right here is undefined. Can't divide by 0. So this whole thing isn't undefined, but it's undefined if we use the power rule. So we must find another rule. Let's check out that rule on the next page. Integration rule for 1 over x. Can you think back when we were doing derivatives? Whose derivative gives us 1 over x? It's 2 different things that give us that. Natural log of x and natural log of negative x. Therefore, integrating 1 over x with respect to x is going to equal natural log of the absolute value of x plus c. Absolute value, because whether x is positive or negative, it gives us the same answer each time. A couple more rules of integration. Integration rules for sine and cosine. If you think back, what's the derivative of sine? Cosine. Therefore, the antiderivative of cosine is going to be sine plus your arbitrary constant. The derivative of cosine is negative sine, Therefore, the antiderivative of sine is going to be negative cosine plus your arbitrary constant. Let's apply a couple of these. Find the following antiderivatives. So we got two different terms, so we do each term separately. The antiderivative of 2 times sine is going to be negative 2 times cosine. The antiderivative of cosine is sine of x, and then we add our arbitrary constant. This is easy if you know the rules. Number 7, this right here, we're dividing by x. If it helps, you could think of this as 4 times 1 over x. So how do you integrate 1 over x? It's a natural log of the absolute value of x. And we had this coefficient here, 4, so that's got to stay there. So it's 4 times natural log of x minus 3. And the antiderivative of cosine of x is sine of x plus your arbitrary constant. This is going to test your sanity because we're doing things that we did earlier this year backwards. 8 t squared, that's just the power rule. I add 1 to the exponent multiplied by the reciprocal of the exponent. The antiderivative of sine is negative cosine. There's already a negative here, so a negative times a negative is a positive. That's going to give us cosine of t plus c. Once again, you get to the point where you integrate and you're like, I don't know if I did this right. Then just take the derivative and see if you end up with what you have up here. And you would find that that's the case. Last example for this video. I would certainly choose to rewrite the square root of x as x to the 1/2. So if we integrate this, we add 1 to the exponent. A half plus 1 is 3/2, multiplied by the reciprocal of the exponent. The antiderivative of sine of x is negative cosine of x. And then we have to add in our arbitrary constant, because when we take the derivative of this, it ends up being 0, and it wouldn't appear up here. That's going to conclude this video. There's going to be a part 2 to this. So to sum up, we got 4 rules of integration now. The power rule, integrating 1 over x, integrating sine and cosine.